Here's our old friend copper 2 sulfate being dissolved in solution. Okay, making a nice pretty blue solution out of this, and we put in some more copper 2 sulfate, and then we put in some more copper 2 sulfate, and you know that the solution is unsaturated until that time where we can dissolve no more crystals at the bottom. They've all entered into solution as much as they're going to, and we have a saturated solution. Okay, but here's something else, right? That we know that those crystals down below are not just sitting there, but some are dissolving at the same rate at the microscopic level that some of them are recrystallizing. So what we've got there is equilibrium. Now if it's at equilibrium, that means then that this concentration of copper ions and sulfate ions remaining constant over time, we can actually plug those into an equilibrium expression and come up with a constant that will describe this solution at a given temperature. So an equilibrium product can actually be determined. So how would we do that? Well, just pick any kind of crystal like, say, calcium chloride solid. And you always write the solid first when you do these solubility type equations. And the reason is because we want to make sure that the number we get in the end when we do the equilibrium expression is the concentration of products over the number 1. So when we write the equation for the dissociation of calcium chloride into its ions, there's calcium 2 positive and chloride. It's a 1 negative charge, and so there has to be 2 of those. When you write the equilibrium expression, it's the concentration of this times this divided by, oh, that's a solid, so we just put 1, see? And so K is going to equal the concentration of the Ca2 positive times the concentration of the Cl negative squared, right? And that equals a value called the KSP, the solubility product constant. So here's what we know. We know then the KSP, or when these concentrations in solution reach a certain value here, that is the point of saturation. So that's also the point where it just starts to form a precipitate. So if we alter certain concentrations, we can still determine, if we know the KSP value, when they're going to precipitate. Well, that's very cool. Here's an example. Somebody says, okay, here's a compound, copper 2 bromate, and we're going to take that copper 2 bromate with its KSP of 1.5 times 10 to the negative 7, and that's at 25 degrees Celsius. And somebody says, well, what concentration does that relate to? I mean, what's the concentration of that chemical in solution before it starts to precipitate at that temperature? Oh, okay. So what you do is, you just take that equation there, always putting the solid first, break it down to its ions, and remember, this doesn't have a concentration, it's a solid. But we can say that it'll dissociate initially into nothing, but eventually it'll change. Remember the icebox, ICE, or initial change equilibrium? It'll change into X concentration here, in a 1-to-1 ratio, but 2X here. So at equilibrium, we have X here and 2X here as concentrations. Okay, so we know then that if we take those and put them into the expression, and here's the expression, remember, it's the concentration of this times this squared, put those numbers in, we will be able to do the math, knowing the KSP goes in for here, and we'll get X at 0.0033 moles per liter. What is that? Okay, it's this concentration here, but it's also, we kind of fudge it, and we say, that's actually the concentration of this chemical, X, and X would be here. The concentration, or here, X would be the concentration of this chemical at the point of saturation. So, this is the concentration that you can have before precipitation occurs of this chemical. If you have more than this concentration, your X value is going to be higher, and you're going to get a Q value here, not a K, but a Q that is going to be greater than this. And when you've got, in this case, Q greater than K, you're going to have a shifting of a reaction back towards this. And so therefore, you have to make more solid, and that means you have to make a precipitate. Now, you're also going to be asked questions, of course. Given the concentration of this and this, can you determine a KSP value? And that's really easy. Just make sure you write the expression, plug the numbers in to get KSP.